Hello, my name is Radhouane Jrad, and I'm presenting you with the usefulness and the power of APIs that could bring to your event-driven architecture. This is part of API Days London 2024. So, I mean, event-driven architecture is a known pattern, and I'm advocating to use the APIs to make it more governable and more useful. So naturally, I'm not advocating for you to get an event hub if you don't have one. The assumption is you have one, and the APIs will bring a lot of goodness to your event-driven architecture. Saying that, it's a good thing to have an event hub in your company. All right, so let's get on, and then you will see what I'm talking about here. So first of all, we're going to define event-driven architecture in case you don't know what it is, or to put it in context. Then we're going to talk about how the API-led architecture and the event-driven architecture are complementary patterns. And then we're going to present you with the framework for EDA API pattern effectively. So what is an event-driven architecture? First of all, this is an old pattern. 1950s started, 1970s became a formal pattern. So it's been around for a long while. Its strength is about asynchronous processes. It allows the provider and the consumer of data to be decoupled, to be independent, and they use what we call the events to exchange data. So what's an event? It's effectively a trigger that signals that something has happened, be it a software or system or environment. In reality, your life is full of events. Almost everything is eventifiable, if that word exists. Your first event is naturally the day you were born. So that event creates triggers a reaction, recording you on birth books, and so on. Now, you might think that the last event of your life is death. It's not. But if they have a gathering 1 year later to remember you, that's an event. So almost everything in life is going around event. That's what makes the EDA more relevant, particularly in the business context. EDA is very close to the business because it reflects the events. And we can take some examples here. There is a change in the tax rates. That is an event, and it generates a need to update, accounting systems, financial systems. For insurance company, there is a policy to be renewed in 3 months' time. So that triggers the start of the pre-renewal process. Stocks reaching, restocking thresholds, that triggers the orders, sometimes automatically, sometimes not. But as you can see, it is a reflection and a reaction to the business going through its normal life. That's why event-driven architecture is about real or near real-time architecture, while the APIs are usually triggered by systems or by schedulers. And that is not an event, it's a false event, if you want. It's not a natural one, like the 3 examples I showed above. So it's great. EDA is a business-focused, in a sense, pattern. And there are effectively 2 main patterns from that perspective. I mean, one is the pub/sub. I guess most people who work with EDA know what the pub/sub is. And as I stated in the previous slide, you have the event producer and you have the event consumers. They're not talking to each other, but they are talking to the event broker, where the messages are put into buckets, what we call topics. Okay, so event producer 1 puts one topic, and there is a consumer listening to that topic and then pulls that message. The advantage here is that the event consumer is not pinging the event producers, and the event producer doesn't care when or if the event consumer picks that message. So that decoupling makes it quite robust. Now, in the last probably decade or so, the pub/sub got elevated into more sophisticated version, where actually we have logs for every movement, if you want, or every event. What that means is you can replay those events. So the unhappy path, the troubleshooting becomes a lot easier. It's you can enforce sequential plays. So the order of topics and whatnot. And obviously from a disaster recovery, it's a lot more robust than just the PubSub. Now, EDA living with the SOA, there is actually an EDA-SOA pattern. And I mean, and actually for people who worked with SOA, and I've worked with this, it's quite robust pattern. However, there is no actual EDA API framework whereby both patterns complement each other. And that's what we're presenting to you today. So what makes them really complementary? I mean, first of all, as I stated 2 slides ago, one is a reactionary to real-time or near real-time events, business events, and one is basically triggerable by other systems. When EDA is strong in asynchronous, API is strong in synchronous, and simple asynchronous as well. So here we're going to go through examples. The first example, very simple, synchronous call from process A to process B, example, get address or whatever. So that's easy. That's a typical API, process. Now, on the other hand, you have a end-to-end pure business, end-to-end asynchronous call or process. That's pretty straightforward. If you have the event capabilities, you should use events for these things. You can use queues and APIs, but organically EDA is more suitable. However, when you get a combination of the two, then it becomes challenging. So the business process, is synchronous, but behind the process B, there is a lot of asynchronous stuff. You can do it with APIs, you can do it with EDA, or you can optimize with a combination of two. Okay, so the idea here is you have a hammer and a screwdriver. You should not hammer with the screwdriver, and you should not screw with the hammer. Okay, right. So there is a concept called domain-driven design. We're going to talk about it in a slide or two. As part of it, there is what we call the anti-corruption layer. So what is an anti-corruption layer? Effectively, it's a layer that you build between two systems that do not talk the same language. In any definition of same language, you might think. Technically, security, business, separation, whatever, okay? Sending an invoice from one system to the other is easy if both they use the same language. So you put some layer in the middle if they don't, and that translates between the two back and forth. Same thing, it separates the good systems, the healthy systems from legacy systems or problematic systems. So the model, the data model or the processing model doesn't creep up to the proper systems. And also it's a defensive mechanism. You can switch off connectivity immediately. So anti-corruption layer is really everywhere, sometimes explicitly, sometimes it's not. EDA is not inherently ACL compatible or capable, okay? You can develop it, okay, but it is very complex, and you have to have multiple buckets and a lot of complex things around, and manage them is a problem. So here comes the APIs. The APIs can very easily play the anti-corruption layer element of your asynchronous or combined architecture, okay? This not only brings both capabilities to the business, but also enrich the security aspect, okay? APIs have a different type of security because they're synchronous compared to EDA, so the business can choose and can combine that element. So that leads effectively to the proposed framework, and this is a framework that actually has been implemented. In the middle, you have the distributed event hub. You can have just a PubSub if you want. And then you have data provider and a data consumer who are not able to send messages to the topic, okay? They don't have the capability, or the business doesn't have the appetite to use that, okay? They want the system to focus on its core activity. So in that case, all they have to do, they have to call an API, an endpoint, and then ask that API, please publish this message for me into this particular topic. The API would have been developed to do these things. And you can see from an ACL point of view, it can block the data provider. It can throttle the input and output and throughput and all these things. So from a security point of view, it's also good. Same thing on the right-hand side. So effectively, on one hand, the data provider is sending data to the API, requests for it to API, and then the API is pushing to the topic to the data hub. On the right-hand side, there are two ways to do it. Either the data consumer is going to be pinged by the API, telling it, hey, I got a message for you, or the API can do some enrichment or whatever, and then goes to the data consumer. The other model is actually the data consumer pinging the API all the time. Do you have a message for me? Do you have a message for me? Oh, yeah, you do have a message for me. So there are two types, but you can see again, you're separating both sides of the equation. Naturally, if the data provider and or the data consumer have the capabilities, which means the ACL capabilities to publish and subscribe, and they fit the security requirements of the company, they can go straight. So the ACL is not part of the event hub, and the event hub is not part of the ACL. The ACL is just sitting there for when it is needed. So it's a complementary pattern to EDA. Okay. Again, this is a repetitive pattern. What that means is multiple data providers can publish multiple messages to the same queue, and multiple consumers can subscribe to one single queue. And we're going to see this in just the very next page. So I mentioned the domain-driven design. And this is I presented this in API Days last year, and it is quite a neat and interesting concept. In complex business context, DDD is almost compulsory if you want to have a control of your software development and lifecycle management. And it comes from the principle that different compartments, different functions in the business, they shouldn't be, when we develop one, you shouldn't have a dependency, you shouldn't on another part of the business. For example, you have the invoicing, and you have human resources, and you have the legal department. So if you're developing code for a legal department, you shouldn't be asking the HR to do some regression testing, So the whole thing is attached for sure, but as you develop, you try to detach them as possible. And a good example I always use is a vessel. You don't want the kitchen, when you build in the kitchen, design in the kitchen, you build in the kitchen, you don't want to say the stove is sitting at the viewing deck, or the captain's corner, and the engine room, you will have the the fridge in the engine room, and so on and so forth. So you develop things quite independently with the bridges between them. So it's a very efficient way to reduce the cost, to be very efficient in developing your APIs, and to be cheap. It's quite costly, effective. Now, EDA is not DDD compliant because it doesn't understand the concept. Okay. However, API, by nature, they are compatible with the domain separations. So you can use APIs, and I have implemented it in large companies. You can use APIs to make your code domain-driven design compatible and to make it very efficient. We use the layered architecture. What that means, effectively, we use the front-end API and then back-end APIs just to separate the access from the actual API work. And we're going to have a look at it here in this example. So this is effectively how I implemented APIs to enforce domain separation, okay, the bounded context in the DDD language. But as you can see here, two different domains, they have two different domain APIs, which are connected to multiple topics. You can look at the EDA stack. It's not really domain bound. So if you already have an EDA that is not domain bound, which is likely, it's okay. The APIs will make them behave and will separate them logically into different domains. You might have a topic that is specific to a domain, just like Lambda here, or just a topic outside of any domain, and anybody can reach out to, like the beta there, okay? And the domain APIs, they are lightweight, okay? So they cannot be heavy loaded. They do basic RAML verification. They do the security but they don't do the likes of transformation. So I was asked this question, and probably it's worth mentioning. I'm not talking about proxy APIs. Okay, in general, proxy APIs are not a good idea. There are some use cases for it, but from a cost and management point of view, they almost, most of the vendors, they charge you the same, and they are stripped of their core, in the middle, that way where you do things. So I'm not advocating for that. What I'm saying is the domain API must not have heavy loading, and the reason for that is because every consumer can have a different endpoint, and that makes cut the regression testing, the nightmare of every project, very, very heavily. So you don't go into versioning, and you don't have to do regression testing. Okay, and and it works. That has been implemented. Now, obviously, if you have some business requirement like enrichment or whatever, you can go to the business APIs inside, and that's the second layer. That's why I talked about layered architecture, and then that will take care of business and such. So on the left-hand side, multiple data providers, multiple data consumers. You can separate the data provision APIs, domain APIs, from the data consumption domain APIs. You can have two APIs, or you can have multiple APIs. But what I wouldn't advocate for is consumer-specific API. Okay, the consumer-specific endpoint, but it's a domain API. It belongs to the domain, not to a particular consumer. Okay, and this is effectively a neat way to turn your EDA into a highly reusable, highly governable. EDA by essence is a lot harder to govern than APIs, and APIs can add a lot of goodness on this. So we saw the ACL role of an API for EDA stack, and we saw how bounded context or separation of concerns that you can implement through DDD and domain APIs. These are very efficient, and if you have any question or comment, just reach out, and I'll be happy to help you. Thank you.